wanted to talk about compound interest as an exponential model. So here is our formula for compound interest. This is the amount that we have. Principal is P, which is the amount that we started with, 1 plus the rate over the number of compounding periods to the power of the number of compounding periods times T, where T is number of years in the cycle. So it's going to look like this. Let's give ourselves some money. So what would this look like? If we had $1,000, how much money would we have 1 month later? So how much money would we have 1 month later? Well, the amount of money we would have would be the principal amount, which is the amount we started with, which is $1,000, times 1 plus the rate is 12%. They're going to give us, let's say they're going to give us 12%. Our rate is going to be 12% interest. So we're going to get 12% interest. So that's 0.12. We have to give our rate as in the form of a decimal. And how many compounding periods in a year? Well, there'll be 12 if it's monthly interest, right? So how many compounding periods will we actually get? We're only going to get 1/12 of one of them, right? Times 1 year. Oh, the number. What did I do? The number of compound. Wow, nobody caught me. The number of compounding periods would be 12. The number of them that we're actually going to get is going to be 1/12, right? We're not going to get a year's worth of them. So here's where some mistakes are made. So this is what I want to talk about. We know that we have Pemdas. I'm going to go back. If your basic arithmetic stays clean, your algebra in your upper level maths will get really, really pretty. So try to stick with this. So it says here that we have to do our parentheses first. Well, 0.12 over 12 is 1/10, isn't it? So it's 0.10 plus 1 is 1.1. Everybody see where I'm getting that? And that makes sense because we're going to get 110% of our money back. This 1 is for 100% of our money. Times 1,000. This thing is going to be 12 times 1/12 is 1, isn't it? Now, this is really important because we could screw this up and still get the right answer. So I want to make sure we're getting the right answer the right way. We're not supposed to multiply this times this until after we've done our exponents. Remember, exponents are the second thing we do. So in this case, it doesn't do anything in this particular case because 1.1 to the first power is just 1.1. So when we multiply, we get $1,010. And that's the total we get back. That's including the money that we put in. However, what would happen if we put the money in for 20 years? So this is, we'd make $10, right? This is after 1 month. But what about A of 20? What if we had 20 years? Well, that would give us 1,000, wouldn't it? Times 1.1 to the 20th power would be equal to some different number. Here's where I can really illustrate the concern that where people screw this up. Where people screw this up is they're going to want to do this. They're going to get excited. I'm going to take 1,000 times this, and they're going to get this value right here, and they're going to look at this. This is wrong. This is wrong. So let me put it in red. So I'm not saying this right. They're going to get $1,010 to the 20th power. Are you crazy? Do you know how much money? I mean, that would be great if you could get that, but that's not true. That's not what's going to happen. First, you're going to raise this number, this 1.1, to the 20th power, then multiply. You're still going to end up with a lot of ching out of this. You're going to end up with $10,892.55. And those 55 cents is count. So, an easy model to use. Mistakes that are made is people don't follow Pemdas. So remember, follow Pemdas. Make sure that you use your exponents before you do your multiplication. All right? Okay. If you haven't already subscribed, please subscribe, and your comments are always welcome. I appreciate them, actually. All right. Ciao.